Hi everybody! Several people requested that we talk about nested loops. So we'll do all of exercise 6, and then some other people wanted exercises 8 and 9, so we'll do those as well. Okay, so nested loops. We did this in class a couple of times during the school year. Let's do it again. So I'm going to tell you how you can think about the execution of these loops step by step, and then also kind of a more global general way of thinking about them. All right, so we know what this part's doing. I is going from 0 up to 4, including 4, because when I equals 5, this test condition is false, and so the loop doesn't execute. Okay, so we could look at this also and say the same thing. What's that loop doing? We're saying j loops from 0 to I. The problem is, well, I guess we'd say not including I. The problem is, I think people are confused about what's this I, because I is also changing. If this was 4, well, we know j is going up to 3, not including 4. But what's it doing when the value here can change? All right, so the trick is, imagine all of this as a single statement. So let's delete the code and rewrite what we said that it does. We said that we loop j from 0 up to I, not including I. And now let's think about what would happen as we run this. So we know that the first time through this loop, I is 0. So that loop that I deleted is going to loop j from 0 up to 0, because I is 0. So that actually doesn't loop at all the first time through. Now we're at the second iteration of the loop, so I is 1. So again, if this was up to I, now we're saying loop j from 0 up to 1. And now the next time through the loop, I is 2, so j loops from 0 to 2, and then 0 to 3, and then 0 to 4. So in other words, what's happening is the inner loop that I deleted is repeating a different number of times depending on which loop of I we're on. So that's how it makes sense that, here, let's go way back. That's how it makes sense that I here changes. It's that you have to know which iteration of the outer loop you're on to know what number this is equal to. And once you know what number that's equal to, now it's like the loops that you know about. Okay, so let me show you a way that you can actually sort of watch this happen. If you click here in the kind of margin, it adds this red circle, which is called a breakpoint. We'll be talking a lot more about this because this is an important way to debug. And then if you click the little bug icon here next to run, that will debug it. And what a breakpoint does is it will pause the execution right at that line. So my program's running, but it's just paused on this line. And then if you hit this down arrow, you can step through your program one line at a time. So as I'm stepping, here it says I is currently 0 because we're the first time through the loop. And it's just about to run this line of code. So it's going to say j equals 0, and then it's going to ask the question, is j smaller than I? But since I is equal to 0 right now, that's going to be false, and so it's just about to skip that line. So watch. See, it skipped it. So now we're back up at the top again, and we run this line, and now it says I is 1, because we did the I++ and then did this check to make sure it's less than 5. So now we're just about to execute the line that's highlighted now. And this time it's going to run because it's going to set j equal to 0. And as you can see, j equals 0, and I is still 1. And now we got to the bottom of the inner loop, and we go back up to the top, and it's just about to add 1 to j. And then it will exit the loop because j equals 1, so it's no longer smaller than the current value of I. So we exited. So let's keep going. So now I is 2, and watch what happens to j as I click. So j is 0, then 1, and now we exit. Now we're back up at the top. I is 3, and watch j loop from 0 up to 2. Here's j is 0, there's 1, there's 2, and now we're done. Now when I is 4, j is going to loop from 0 to 3. Loop, 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 loop. Done. And now we're done. So the way that you want to think about what's happening is you can, I like to sort of phrase it this way. I goes from 0 to 4, and then for the inner loop, you can think about it this way. For each value of I, you're going to do the following. You're going to loop j from 0 up to like 1 less than I. So it's this for each value of, that's the trick for thinking about these. For each of these numbers, you do all of this. So we can see what I said reflected in the output when this actually runs. The outer loop is looping 5 times total, 0, 1, 2, 3, 4. Then in the inner loop, we're always looping from 0 up to 1 less than I. So the first time through, it prints nothing because I is 0. The second time through, when I is 1, we print from 0 up to 0. Then from 0 up to 1, then from 0 up to 2, then from 0 up to 3. So that's what the inner loop is doing. It's printing from 0 up to whatever loop number we're at. And then we have a new line, which moves the output to the new line. Okay, part A says, how could we make these count down to 0 on each line instead of up from 0? So instead of saying 0, 1, 2, could we make it say 2, 1, 0, like that? So that's controlled by the inner loop, because j is the number that actually gets displayed here. So instead of starting j at 0 and going and adding 1 every time and going up to I, what we really want to do is start at I, or maybe I minus 1. We'll think about it in a second. We're going to go down by 1 every time, and we're going to keep going as long as we're larger than or equal to 0. So that's going to count down. Let's see what it looks like. So here, we count from 0 down to 0, then 1 down to 0, 2 down to 0, 3 down to 0, and 4 down to 0. So that seems like what we want to do. You'll notice that this is a little bit different than the last one, because in the last one we only saw 4 lines of output, and here we see 5 lines of output. Because in the last one we didn't actually display a line where we were counting from 0 up to 0, and in this case we are. So my problem was a little bit ambiguous, so you could do either one if you wanted to. If you want it to be more like the last one, we could start at 1 minus I, and that's going to output something that just leaves off the last one. Okay, so the last part of the problem said, so after you're done printing the numbers, how can you add another loop that keeps printing zeros until that you reach the end of the line so the output looks like a square? So I want to put my print statements before this one, because this is the one that actually sends me to a new line. I know that I want to have several print statements in a loop. So I'll say, like, for int a equals 0, a is less than I don't know what, a plus plus. But the reason I knew to do this is because I know that I want to have a print statement that prints 0 several times. So this is a great way to program if you don't know how to think about the whole thing all at once, which is usually, is you put in the parts that you know you need and then start thinking about, like, what are the missing pieces that will make it do what you want it to do. So I know I want to print zeros, so I've got a print statement. I know I want to print multiple zeros, so I know I need a loop. So now the only part that's missing is, how often do I need to loop? Well, let's count. So the first time through the loop, I need, let's see, 1, 2, 3, 4. And then the next time through the loop, I need 1, 2, 3, and then I need 2, and then I need 1. So an easy way to think about this is you could just define a new variable. So like zeros needed, we'll start it at 4, and now we'll say loop a from 0 up to however many zeros we need. And then when we're done, we'll subtract from the number of zeros needed. So that way it'll be like 4, 3, 2, 1. So this is not maybe the best solution, but I think this is going to work. So let's run it and see what happens. Oh, do I not? Oh, so we've got to have a space in here. Oops. Let's run it again. Okay, great. So that seems like it's worked. It's made a square output. The reason this is not my favorite solution is because you don't necessarily need a separate variable, because the number of zeros you need is related to the value of I. So the first time through the list, when I equals 0, we need 4. When I equals 1, we need 3. When I equals 2, we need 2. So let's sort of write this down and think about it. So when I is 0, we need 4. When I is 1, we need 3. When I is 2, we need 2. When I is 1, we need Nope. Sorry. We need 1, and so on. So where does this number come from? We could say 4 minus I. So 4 minus 0 is 4. 4 minus 1 is 3, because I is 1. 4 minus 2 is 2. And then 4 minus 3 is 1. So it seems like as I is going up, if we say 4 minus I, the number of zeros we need is going down in the way that we need it to. So instead of having zeros needed, we could say, let's keep looping as long as it's less than 4 minus I. And let's run that and see if that's going to give us the same thing. And it does. This might seem less readable, so one compromise solution you could do if you feel like readability is more important than concision, being concise, is you could define something like zeros needed equals 4 minus I, just so that it's clear what's happening, and then you can put zeros needed right there. And that's nice because then you kind of see what's going on, but you're still defining it this way. Different approach could be put a comment. You could say 4 minus I is number of zeros needed. And that explains the thing that might be potentially confusing to another programmer where you see it there. So those are all possible solutions. For problem 8, we were wondering how often you'd have to roll 3 6-sided die until they each show a 1 at the same time. And we were going to do that experimentally rather than using math to figure out what the expected number of rolls would be. So what we're going to do is we're going to write a while loop, which will generate 3 random numbers, 1 for each of the die. And we're going to keep looping as long as they aren't all equal to 1. So if any of them isn't 1, then we'll go back and roll again because we haven't met the condition that we're interested in. A couple people asked, do you use a while loop or a do while loop? The difference is in a while loop, you have the loop test for whether or not you should execute the body right at the top. And for do while, you execute the body of the loop once no matter what, and then the test for whether or not you would go back and execute it again happens at the bottom. So in this case, I know that I want to roll the die, all 3 die at least once. So I want to execute the thing that I'd be repeating at least once. So I think I'll keep a do while loop. So I'll have die 1, die 2, die 3. And for each one, I'll cast to an int. And I'll have math.random times 6. So that would be an integer between 0 and 5. And then I'll add 1 at the end. There's lots of ways that this thing could look. That's one of them. So I'll do that for all 3 of them. So that's die 1 and 2 and 3. And I want to keep rolling while all 3 of these aren't equal to 1. So I could say it this way. While it's not true that the condition I'm interested in is happening. And the condition I'm interested in is die 1 is 1, and also die 2 is 1, and also die 3 is 1. So this is all 3 of them are 1 at the same time. And so while that's not true, I would want to go back and do it all again. You might be so I'm going to talk through a couple of other things you could put here. You might be wondering why it says it cannot resolve the symbol die 1, because here's where we declare it. The problem is we've declared it inside the block defined by these curly braces, and the condition in the while loop is outside the block. So it can't actually see that this is a declared variable. So let's declare them at the top like this. Die 1, die 2, die 3. And then we'll just assign them values inside the loop. Okay. And I guess let's finish it out. The whole point here is we wanted to count how many times it was going to take. So let's add a count, which I'll initialize to 0. And then I'll say count plus plus after I've rolled all the die once. Cool. And now it took, and then how many times it took. Let's run it. You might be wondering, how can you test to see whether this really works, because it said 37. A really easy thing you could do would be inside the loop just print out what all your die values are so that you can just like manually see if that was really the first time that they were all equal to 1. In fact, I'll just do that really quickly. So die 1 and a space, and die 2 and a space, and die 3. Let's run it one last time. Cool, and so if I kind of visually scan, doesn't seem like all 3 of them are 1 until the very end here. I don't really want to count 83 times, but that doesn't seem insane. Seems like it could be right. Let's talk about what else we could put in this condition. So I'm saying, so I imagined I was writing like an if statement. Like I would want to say, if this is true, like then stop. If all 3 of them are 1, then stop. So the while condition is whether or not we should keep going, whether or not we should keep looping. So I want to keep looping if it's not true that the condition is met. So I have the condition that I would write for stopping, and then I say, when that's not true, keep going. And the bang here is for when that's not true. A different way you could write it would be, well, die 1 is not equal to 1. Oops. And die 2 is not equal to 1 also. And die 3 is also not equal to 1. So this is actually wrong, the way I've written it right now, because what this is saying is keep looping as long as all 3 die aren't equal to 1. That's what the ands are about. Because remember, and means both conditions have to be true. So this would actually be saying keep rolling the die as long as all 3 of them are different from 1. But what I really want to say is if any of the 3 is not equal to 1, then keep going, because I know that all 3 can't be 1 if any of them are different from 1. So that's what or would be for. I'm saying if die 1 isn't 1, or if die 2 isn't 1, or if die 3 isn't 1. If any of them aren't equal to 1, keep going. And that's equivalent to the first thing that I wrote. Problem 9 is similar. We're going to be using a loop where we ask the user to type a number, and we'll keep doing that as long as it's, well, let's see. We'll keep doing that until it's an odd number between 10 and 20. Nope, an odd number between 10 and 15. Great, so we'll have usernum. I don't know if we're supposed to be counting. I'll go ahead and use a JOption pane here. So string response equals JOption pane. Yikes. So type a number. And then usernum is going to be equal to integer.parseInt. What's going wrong here? For response. And let's do the same approach that I used last time. So let's imagine I'm writing an if statement for testing when I'd want to stop. So I'd want to say like if usernum is odd, so if usernum mod 2 is equal to 1, and also usernum is between 10 and 15. So 10 is less than or equal to usernum, and usernum is less than or equal to 15. So if all of that is true, then I know that I want to stop. So I want to keep going if all of that is not true. So I'll take my condition, paste it here, and say not. So that would work. Or I could think about, I want to keep looping if any one of these is not true. So I want to keep going if usernum mod 2 is not equal to 1. Or I want to keep going if it's not true that usernum is greater than or equal to 10. Some students try and do something like put a not here. You can't really do that. But if you think logically, what is true about usernum if it is not larger than or equal to 10? It must be less than 10. So if usernum is less than 10, I know it's bad. Or if usernum is not less than or equal to 15, so in other words, if usernum is bigger than 15, that's also bad. So this is equivalent to what I had before. All I did was I took each condition and I figured out what's the logical opposite of that, and then I combine them with ors, because if any one of those is happening, then I know that all of my conditions aren't being met, so I'd go back and do it all over again. Cool. Let's run it. and see if it works. So I'll type an odd number that's too small. Well, that didn't work. Ah, I see why. This should be the other direction. If user num is smaller than 10, then it's bad. If user number is bigger than 15, then it's bad. Okay, let's do it again. So I'll enter an odd number that's too small, and it wasn't happy. I'll enter an odd number that's too big, and it's not happy. Let's enter an even number that's in the correct range. Not happy. Let's enter an odd number that's in the correct range, and now it's happy. That's it. I hope it was helpful. Some people were asking about problem 12, the bonus problem. There's a separate video for that one that I recorded last year or 2 years ago or whenever I recorded it. Have a happy 4th of July. I'll see you next time.